All right, section 7.2 is where we're going to be solving linear systems by substitution. That's what we're going to be doing. Okay, solving linear systems by substitution. So when we were talking about linear systems back before Thanksgiving break, we talked about solving them by graphing, and we looked for where the two lines were crossing. If they crossed, how many solutions were there when they crossed? One. If they didn't cross, the lines were parallel, and there were how many? No solutions. And if they were the same line, infinitely many solutions. Those were the three scenarios that could happen. We could have one solution, no solutions, or infinitely many solutions. Those same three scenarios can happen with substitution. We'll see what that looks like as we go along here. But substitution is an algebraic way of solving a system. Instead of having to draw a graph and find that point where they cross, because if they didn't cross at a really nice point, you had to kind of guess at is that 1.4 or is that 1.3? It's real hard to tell the difference in those two if you try to do that with a graph. But with the algebra method or algebraic method, then you get exact answers and you can get it, right on the spot. So we're going to do this with substitution, which is a pretty good method. It's good to know substitution method and elimination method both. We'll talk about elimination tomorrow, Wednesday and Thursday, or Wednesday. Yeah, tomorrow, Wednesday and Thursday. But there's, being able to do both methods. You can like one more than the other, but you got to be able to do both of them, especially when you get to Algebra 2. When you do three variable systems, they get being able to do both methods can be very, very helpful in solving those. Or if you only have one that you're good at, you can struggle because it just takes longer to work them. So let's start with this one. 3x plus 5y is equal to 17. And the second equation is just y equals 4. Okay? So they give us what y is equal to. So what we're going to do with substitution is we're going to take whatever y is equal to, since it's equal to just 4, we're going to take that and substitute that back in to the other equation for y. Real simple. Substitution means you replace something. So we're going to replace y with 4 in this problem. So that's going to be 3x plus 5 times 4 is equal to 17. And that's now we've got an equation that's only got x's in it. So we have 3x plus 20 is equal to 17. And then how do we solve that? Subtract the 20, from both sides. 17 minus 20 would be negative 3, and then divide by 3, x is equal to negative 1. So we get x is equal to negative 1. We already know that y is equal to what? 4. So we have this ordered pair that's the solution, negative 1, positive 4. Always going to get if there is a solution, it's going to be an ordered pair solution, just like it was with the graphing where there was the place where they cross. What that means is if we graphed both of these equations, they would cross at that point, negative 1, 4. But I'd much rather do that than graph, honestly. Graphing takes a lot more time, a lot more room to do that. That's much more straightforward. Okay, so let's look at example B. Let's say we had one that said x equals negative 5, and then the second equation is 2x minus 3y is equal to 11. So what are we going to substitute on this one? Negative 5 in the place of x. So we're going to take this negative 5, put it in the place of that x. And then we will solve that equation for what? For y, So we have 2 times negative 5 minus 3y is equal to 11. And I always, when I plug that in, put parentheses in there. That will help you keep, the negative sign straight and stuff like that. Sometimes we kind of mess up sometimes or I do anyway, if I don't put the parentheses in there. So I always put those parentheses in there. 2 times negative 5 would be negative 10 And then what do we do next? Yeah, plus 10 to both sides. So that's going to be negative 3y equals 21. Divide by negative 3. Y is equals negative 7. So our ordered pair, that's our answer, is what? Negative 5, negative 7. Remember, x always comes first in our ordered pairs. Okay. Negative 5, negative 7. X, then y. Always. So, not too bad so far. They give us what one of the letters is equal to. We plug it in and find the other one. Not too bad. Let's see about this next one. All right. Example C. Ooh. 10x plus 6y is equal to 22. Okay. And then the second equation, y equals, let's do 2/3. A fraction and throwing that in there. So 10x plus 6y. Handwriting's atrocious. I don't think I've handwritten anything since we've been off. What do we do? Yeah. 10x plus 6 times 2/3. Equals 22. What's 2/3 of 6? 4. So we have 10x plus 4 equal to 22. Subtract the 4. 10x is equal to 18. Now what? Divide by 10 on both sides. Does 10 go into 18? So what do we do? Reduce the fraction. So 18 and 10 are both divisible by 2. So that would end up being 9/5. Final answer is an ordered pair. Over 5, 2/3. Now, that definitely is an example of one that's better by algebraic methods than by graphing. Because I don't think any of us could eyeball 9/5, 2/3. That'd be very difficult to do. Bless you. Bless you again. And again. Molly's been away from the school for a few days. She's allergic to it, so it'll take her a minute to get back. Yeah. All right. I ain't sneezed, are we? All right, let's look at one that gets a little bit tougher in the fact that they don't give us one of the answers first. They do help us out in that we get one equation is x plus 2y is equal to 11. And then the second equation is y equals, but instead of just giving us a plain number, they say y is equal to 3x plus 2. All right. So, method is the same, though. We know what y equals, right? It's equal to 3x plus 2. Molly? I wouldn't.
Substitute 3x plus 2 for y.
Yeah, since we've already got something that's got a letter by itself, let's just take this and substitute it in here. And do distributive property. Yeah, that's right. So we're going to take this part and replace y in that equation with it because we already have something that y equals. It's not a nice number, but it is something that y equals. So we're going to take that and have x plus 2 parentheses 3x plus 2 is equal to 11. And Eli said we would do the distributive property, and that's right. So that's where the parentheses, getting in the habit of doing that with the number problems, makes it, just second nature to do it here. And we know that this is distributive property, 2 times x, 3x, and then 2 times 2. So that'd be x plus 6x plus 4 is equal to 11. And then I can simplify that side, right? Yeah, it'd be 7x plus 4 is equal to 11. Oh, 7 looks so dumb. And then we can subtract 4. 7x equals 7. So x would be what? 1. So my pen is not doing it right. All right, so divide by 7. X is equal to 1. What's y? We don't know. Yeah, go ahead. Yeah, we can take that 1 and plug it in right here, and just work out that side, and it's going to give us what y is. So y equals 3 times 1 plus 2. That'd be 3 plus 2, which is 5. So y is equal to 5. Ordered pair is 1, 5. Okay, so a little more work involved here, a little longer, but it's not very difficult work either way. Once we get here to this first purple line, that's chapter 3. Problems just like we did in chapter 3. Once we get that answer and plug it in, that's again, that'd be like the first section of chapter 3. All right. Let's look at another. Example E. Negative 2x plus y is equal to negative 3. And then the second equation is x equals negative 3y plus 5. What did they give us? They gave us the stuff that x is equal to. Hayes, why don't you get your stuff and move over here behind Emily? Get you and Mitchell can sit by each other. Okay, so we have something that x is. So what are we going to do with that stuff? Plug it in for x. So we're going to take this part and replace the x with it. So that's going to be negative 2, parentheses, negative 3y plus 5 plus y is equal to negative 3. What do we do next? Distributive property. So that's going to be 6y minus 10. Yeah. And then simplify that. So 6y plus y would be 7y. Be careful. You're on the same side, so 6 and 1 would be 7. You're not subtracting because you're not moving across the equal sign with the y's there. You're just combining positive 6 and positive 1. That's one of the most common mistakes with this stuff is doing the opposite when you're on the same side. Next move would be add 10. 7y is equal to 7. Divide by 7. Y is equal to 1 this time. How do we get x? Plug it in for y in the x equation. X would equal negative 3 times 1 plus 5. It'd be negative 3 plus 5 is positive 2. So x is positive 2, y is positive 1, so it'd be the ordered pair 2, 1. That ordered pair is the final answer that you're after here. Now, we hadn't done this on the previous problems, but anytime you get an ordered pair as a solution, you want to know, is it right? You take that ordered pair, plug it into both equations and make sure it works. 2, 1, that'd be -4 plus 1 is -3. So it works in the first one. If I plug it in the second one, that'd be -3 plus 5 is +2. That's what x is equal to. So it works in both of those. Checking solutions is just plugging it into both of them and make sure it works in both equations. If it doesn't work in both of them, then it's not the answer. Or you either mismultiplied or misadded somewhere when you were checking. All right, let's step it up to the next level. Okay. So far, they've been giving us a problem that had x equals this, y equals something. Okay, that's what they've been giving us. They don't always give you that. They may give you an equation that says x minus 2y equals -6. And then the second equation might be something like 4x plus 6y equals +4. Okay? Neither of those says x equals this or y equals something. But one of them is pretty close to that. The top one is almost got x by itself. It would be one step to get it there. How would I get x by itself in the top one? If I add 2y to both sides, that's going to give me
Mr. Isbell?
Yes, ma'am.
I will check it out.
All right.
Okay.
Thank you. You can't. They're not like terms, but you can add them in. You can't add them. That's true. But you can have them over there and have -6 plus 2y, just written like that. You can't put them together, though. That's right. Good job, Autumn. That is true. Okay. Now we have something that x equals. So we can take this and replace x in the other problem, just like what we've been doing. 4 parentheses, -6 plus 2y, and then plus 6y equals 4. So again, it's distributive property with the 4 in the parentheses. So that's going to be -24 plus 8y plus 6y equals 4. And we do have some like terms there that we can put together. 8y and 6y would be 14y. So we have -24 plus 14y is equal to 4. Now what? Add 24 to 4. And we can't add those because they are like terms. 14y is equal to 28. Divide by 14. And 14 go into 28 twice. So it's 2. So y is equal to 2. How do I get x? Plug it back into the x equation. X was supposed to be equal to -6, plus 2y. So I'm going to plug in, instead of the y, I'm going to put a 2 in that place. So it'd be -6 plus 4, which would be -2. Ordered pair, -2, 2. It's supposed to be the hard ones. It's not that bad. Okay. Look at another one. Example G. Say we have x minus y is equal to 3, And the second equation is x plus 2y is equal to negative 6. So here we have two equations that are both almost set up. So we just need to make a choice. Which one? I like the top one because you get rid of the negative sign by adding y. So I like that one better than this one because you'd have two negatives in it to deal with. So yeah, adding y on the top one gets that to be x equals y plus 3 or 3 plus y. It doesn't really matter which way you write that. I wrote it y plus 3 for no apparent reason. What are we going to do with that part? Plug it into the other equation. It has to go into the other one, can't go back into the one it started from. Okay. Plug that in there. There's nothing to multiply by, right? So that's just going to be y plus 3 plus 2y is equal to negative 6. What happens on this side? Well, combine like terms. So y plus 2y would be 3y plus 3 equals negative 6. And then what? Minus 3. So that'd be negative 9. And then Adam said divide by 3. Yeah, so y is going to be equal to negative 3. And then we're going to take that and find the x with it. So we're going to go to that x equation, which is 0. Ordered pair would be 0, negative 3. And if we try that in the original problems here, 0 minus negative 3 is 3. 0 plus 2 times negative 3, that is negative 6. So that is the correct answer. It works in both of the original problems. So you can always check to make sure it's working there. Yeah, we got time for one more. And then that'll be it. So if we can get this one in, we're done. And you'll have the time afterwards to work. So here's the last example. 3x plus y is equal to negative 7. And then negative 2x plus 4y is equal to 0. Okay. Which one do we want to get a letter by itself in? Yeah, that top one looks like the easiest one. Anytime you see a letter that's by itself, it doesn't have a number in front of it, then that's the one you want to try to get with that letter by itself. So how do I get y by itself? Yeah, just minus 3x on both sides. So that's going to convert over to y is equal to negative 3x minus 7. If you wrote negative 7 minus 3x, it's the same thing. It doesn't really matter at that point. I wrote it in that order just because that's slope-intercept form is how I normally write them. Okay, now what do I do with that? Plug it in for y in the second equation. That's going to be negative 2x plus 4 parentheses negative 3x minus 7 is equal to 0. So that'd be negative 12x minus 28 is equal to 0. Combine your like terms. Now what? Add 28, good. 0 plus 28 is 28, that's easy. Divide by negative 14. What's x? Negative 2. What do we do to get y? Plug it in. Negative 3, parentheses, negative 2, minus 7. So that'd be 6 minus 7, which is, yeah, negative 1. Good job. So there's y, ordered pair, negative 2, negative 1. That's it. It don't get much tougher than that, honestly. I mean, this is a pretty simple skill set, not anything surprising about these kind of problems, okay? So So when you come back from lunch, your assignment that you're going to work on is going to be page 439, numbers 3 through 17, 21 through 27. We'll start out with just the odd ones, but if we can't handle that, we can definitely take odd off of that, make it all of them. Also remember that your makeup work that you, missing assignments that you might have, some of you have turned in several. If you are missing some assignments, that they are due Friday of this week, no later. Okay. Freeze through.